In this video, I am going to discuss about the different types of the lens and also lens maker formula. But in the previous video, already I have discussed about the refraction through concave refracting surface or refraction through concave spherical surface, and I had given you, please you go through the refraction through the convex refraction surface. Even everything method is same, everything is same, and at the last the formula will also come same. Second thing, when we derive the expression for the refraction through either concave spherical surface or convex spherical surface, in both cases, if the rays is going from rarer to denser, then we have derived the formula n upon v minus 1 upon u is equal to n minus 1 upon r. And when the rays is going from denser to rarer medium, it means if the object is in the denser medium, means the rays is going from denser to rarer medium, then in the same formula at the place of n we will take 1 by n. And that thing will be same. As you know, there are the different types of the lens. Like this, in the case of convex lens, suppose this one is called biconvex or double convex lens. This one. And in short, you can say only convex lens. It's also there. So this one is biconvex or double convex lens. If it's one surface or one face is plane, and remember this, for plane surface, its radius of curvature is infinite. For plane surface, the radius of curvature infinite. So plano-convex means one surface is plane and other is convex. This one. So this surface is plane. This one is called plano-convex lens, and this one is called concavo-convex lens. So this is the type of the different types of the convex lens. What type? Biconvex or double convex, plano-convex, concavo-convex. In same way, there are different types of the concave lens also. This one is called biconcave or double concave lens. This one is called plano-concave, in which one surface will be plane, and this one is called convex to concave lens. And I hope maybe also you have studied in the class 10th the different terms related to the lens, like optical center, focal length, focal plane. So all these things I hope maybe all of you know. So I am going to discuss. Next is what here, lens maker formula, which is very very important. I hope maybe all of you know a convex lens is also called converging in nature, because when a parallel ray of light is fall on a convex lens, then after passing through the convex lens, it will be converged. So this one is also called converging lens, and concave lens is also called diverging lens, because when a ray of light which is parallel to the principal axis, when passes through the concave lens, then it refract. What here? It diverge. So in this way you can say convex lens shows the converging nature and concave lens shows what nature here? Diverging nature. And the focal length of convex lens is positive and focal length of concave lens is taken negative. Because when you will take the focal length of convex lens, so it will comes when a parallel ray of light which is parallel to the principal axis, when fall or after passing through the lens, it will meet at a point on the principal axis, and that point is called its focus, and its distance from the optical center is called focal length. And when you will see in your book, then it writes on the right hand side of the optical center. So focal length of convex lens be considered positive and focal length of concave lens negative. So remember this. So the power of convex lens be also positive and power of concave lens will be what here? Negative. So refraction of light through thin lens. Thin lens means the thickness of the lens is very less. And this one is what? Lens maker's formula. This formula is very very important for your examination point of view. Now you see here. Suppose this one is a convex lens, thin convex lens. This one. and there are the two surfaces. First surface is suppose first surface 1, this one, and this one is surface 2, second one, this one. One surface is A and second surface is B. And this one is what here? A principal axis which is passed through its optical center. See, P1 is the pole of this first surface, chord surface, and P2 is the pole of the second surface. So P1 and P2 be the pole of these two spherical surfaces. C is the optical center of this lens, you can see. And now you see, suppose there are two spherical surfaces. So here we will take the two center of curvature. What? For this spherical surface, its center of curvature is on the right hand side, means C1. And this C1 is, you will take this one. This. So C1 is the center of curvature of this first surface. And the distance of C1 from its pole P1, it means this distance P1 C1 is called R1, radius of curvature of the first surface. Similarly, for the second surface B, this one, for this chord surface, its center of curvature should be lies on left hand side of it. It means its center of curvature is this one. So C2 is the center of curvature of this second chord surface. And the distance of C2 from its pole P2, it means P2 C2 is R2. It means center of curvature for this first surface A is C1, whose distance from P1 to C1, which is called radius of curvature R1. And similarly for the second surface, its center of curvature C2, and its distance from P2 is P2 C2, which is radius of curvature for the second surface, which is what here? R2. Now, next one. Next step. What is the normal on these two surfaces? And you know, if you want to draw the normal on any spherical surface, then you will draw a line which is passes through its center of curvature. So it means what is the center of curvature of this first surface? This one, its center of curvature is C1. It means when you will draw a line on this curvature chord surface from C1, which one? This dotted line, this one will be act as a normal on this first chord surface. First spherical surface. It means C1 A and 1 is the normal on first spherical surface. And similarly, for the second spherical surface, this one, C2 is the center of curvature. And the line draw from the C2 on this spherical surface is what here? C2, B and 2, which will be act as a normal on second surface. So I hope maybe C1, C2, P1, C1, P2, C2, and normal C1, A and 1 and C2, B and 2. All this term is clear. Next, this one is the principal axis. And suppose a object O be placed, any object O be placed at this point on the principal axis. हम मान लेते हैं कि इस principal axis पे, इस लेंस के principal axis पे कोई object O रखा है. So when a ray of light started from this point O, जब O से कोई ray of light चलेगी, so this ray of light is going from rarer to denser. ये एयर से लेंस में जा रही है और हम ये मान रहे हैं कि सपोज refractive index of this denser medium means lens with respect to rarer medium and surrounding medium is n. जैसे कि हम प्रीवियस वीडियो में बताए थे, n क्या लेते थे? refractive index of denser medium with respect to rarer. तो यहाँ पे denser क्या है? ग्लास. रेयर क्या होगा? ये सराउंडिंग मीडियम जिसमें ये रखा है। हाँ, जैसे अगर सराउंडिंग मीडियम एयर है तो आप लेंगे रिफ्रैक्टिव इंडेक्स ऑफ ग्लास विद रिस्पेक्ट टू एयर। अगर कोई लिक्विड है तो रिफ्रैक्टिव इंडेक्स ऑफ ग्लास विद रिस्पेक्ट टू दैट लिक्विड ये ले लेंगे। सो when a ray applied which is started from this object is going from rarer to denser, and you know when a ray applied is passes from rarer to denser, then it bends towards the normal. वो normal की तरफ क्या होती है? झुक जाती है। What is the normal? So first reflection will take place from the first surface. इस first surface से reflection होगा और इस first surface के लिए rays ये जो जा रही है ये incident ray वो जा रही है rarer से denser. It means it bends towards the normal. What is the normal on this first surface? C1A1. इसलिए ये ray of light after refraction it will not go straight सीधे न जाकर के बल्कि इस normal की तरफ क्या कर गई है? झुक गई है इधर आ गई। So this rays after refraction bends ये जो normal C1A1 है इसकी तरफ ये झुक गई। And after refraction through the first surface, the refracted rays goes along AB. अब क्या हो गया? For this first surface, object is O, and its distance from this first surface is what? How much here? U. And remember this: if the first suppose second surface is upside, अगर ये second surface ना होता तो यही रेज जो है वो सीधे कहां जाके मिल जाती? ये जो रिफ्रैक्टेड रेज थी at what point? I dash. It means this first surface will form the image of this object at what place? I dash. इसका मतलब पहला सरफेस इस ऑब्जेक्ट O का इमेज कहां बनाया होता? I dash पे। और पहले सरफेस का इस ऑब्जेक्ट से डिस्टेंस कितना हो गया? U। और पहले सरफेस ने इमेज कहां बनाया? I dash पे, जिसकी इस P1 से डिस्टेंस कितनी हमने ले लिया? V dash। तो फॉर फर्स्ट सरफेस distance of the object U, distance of the image V dash. Rays is going from rarer to denser. I hope maybe it's clear. Now for second surface, this one, now AB, this refracted rays will act as a incident ray. अब रेज ये जो पहले सरफेस से जो रेज रिफ्रैक्ट हुई थी अब दूसरे सरफेस के लिए किसकी तरह काम करेगा? इंसिडेंट रेज की तरह। और जब दूसरे सरफेस के लिए इंसिडेंट रेज की तरह काम करेगा तो फॉर द सेकंड सरफेस दिस रेज इज गोइंग फ्रॉम डेंसर टू रेयर। कहां से कहां जा रहा है? डेंसर टू रेयर। And when a ray of light is passes from denser to rarer, then it goes away from the normal. इसका मतलब इस सेकंड सरफेस पे जो नॉर्मल है C2B2, इससे रिफ्लेक्शन के बाद रेज क्या होगी? जाना तो उसको ऐसे चाहिए था लेकिन ये नॉर्मल से दूर होके इधर चला गया। एंड फाइनली इट मीट एट व्हाट पॉइंट ऑन द प्रिंसिपल एक्सिस? I। इसका मतलब I dash we serve as a virtual object for second surface. दूसरे सरफेस के लिए ऑब्जेक्ट कहां है? क्योंकि ये ऑब्जेक्ट वो तो हम पहले सरफेस के लिए ले चुके, तो फॉर सेकंड सरफेस दिस इमेज I dash will serve as a virtual object whose distance from P2 is how much? How much here? Whose distance from P2? This one is actually I am taking here this distance from here to here. This one is V dash. This distance becomes how much here? V dash minus T. So when I dash will serve as a virtual object for the second surface, तो for second surface distance from P2, क्योंकि second surface ये है, अब distance P2 से I dash मतलब ये उसके लिए U होगा जो कि इसके बराबर है V dash minus T। और फाइनली इस I dash का इमेज ये सेकंड सरफेस कहां बना देता है? I पे, जिसकी P2 से डिस्टेंस कितनी है? यहां से अब मेरी बात इसलिए in this whole refraction process 2 times refraction will take place. First time through the first surface, when the rays is going from rarer to denser, and second time from the second surface when the rays is going from denser to rarer. And for when refraction will take place from the first surface, then object is O, image is I dash. Distance of the object from first surface U, and distance of this I dash from this first surface is how much here? V dash. And when refraction takes place from the second surface, then now this I dash will act as a virtual object. इसका मतलब सेकेंड सरफेस के लिए u की वैल्यू कितनी हो जाएगी? v dash minus t. And for the second surface, what is the distance of the where image will form? At I. So find the distance of P2 to I. This image distance is how much here? So be careful about this one here. How many times the refraction will take place? 2 times. First, rays is going from rarer to denser, and second time the rays is going from denser to rarer. Already I have told you the formula for the refraction through a spherical surface, चाहे वो spherical surface concave या convex, मैंने पहले बताया था. क्या फॉर्मूला ड्राइव किया था? n upon v minus 1 upon u is equal to n minus 1 upon r. This formula we have derived when rays was going from rarer to denser medium. And if the rays is going from denser to rarer, so at place of n, what you will take? 1 by n. n है क्या? Refractive index of denser medium with respect to rarer medium. So first we consider how many times the refraction will take place here? 2 times. So first we consider for refraction through first surface. So for refraction through first surface, and when you will take for refraction through first surface, apply this formula. क्यों? क्योंकि रेस कहां जा रही है? रेरर से डेंसर, और रेरर से डेंसर में जाएगी तो ये फार्मूला लगाएंगे, और डेंसर से रेरर में जाएगी तो वही n की जगह पे 1 by n कर देंगे. v क्या है? v है डिस्टेंस ऑफ इमेज फ्रॉम दैट सरफेस. जिस सरफेस से हम रिफ्रैक्शन लगा रहे हैं उस सरफेस से डिस्टेंस ऑफ इमेज को डिनोट करेंगे v, उस सरफेस से डिस्टेंस ऑफ ऑब्जेक्ट को डिनोट करेंगे u, और उस सरफेस का रेडियस ऑफ कर्वेचर क्या होगा? r. सो फॉर फर्स्ट सरफेस अब बताइए व्हाट यू विल टेक? डिस्टेंस ऑफ v. v मींस फर्स्ट सरफेस विल फॉर्म द इमेज वेयर. फर्स्ट सरफेस इमेज कहां बनाया था? I डैश पे, जिसकी P1 से डिस्टेंस कितनी थी? V डैश. तो व्हाट यू विल राइट हियर? n upon V dash minus for first surface, what is the distance of the object? U. So n upon V dash minus 1 upon U is equal to n minus 1 upon what is the radius of curvature of this first surface? P1 to C1 over this one R. So you write here this one is R equation. Now for the refraction through second surface, अब इस surface से लेना है, but for this surface rays is going from denser to rarer. So first in this formula at place of n, what you will write? 1 by n. And V means distance of image from the second surface. Finally second surface कहां image बनाया है? I पे. तो P2 से I तक की डिस्टेंस कितनी है? P. तो 1 upon n. यहां पे हमने n की जगह क्या रखा है? 1 by n. Why? Because the rays is going from denser to rarer. Minus 1 upon U. 1 upon. For second surface, who will act as a object? I dash. और I dash की second surface से distance का कितनी है? From here to here, this one is how much here? V dash minus t. इसका मतलब U इसके लिए क्या हो जाएगा second surface के लिए? V dash minus t. So this one is V dash minus t. This is equal to 1 by n minus 1 1 by n minus 1 upon, here you will write R2. So in this way, you can write the expression for refraction through first surface as well as refraction through second surface. So when you will take the refraction from the second surface, then at place of n you will write 1 by n, and at place of Vu, as you know, at place of R finally you will write here R2. And now you see, here this one is 1 upon nv minus 1 upon v dash minus t. This one is 1 upon n minus 1 upon R2. So you can write here 1 upon nv minus 1 upon v dash minus t. Here you can write 1 minus n upon n R2. And यहाँ पे ऐसे ले लीजिए. Now what you will do? यहाँ है 1 upon n, यहाँ भी 1 upon n. Multiply both side by n. दोनों तरफ क्या कर दें? n से multiply कर दें. Now multiplying both side, multiplying by n both side, इसमें दोनों तरफ n से multiply कर दीजिए. So this becomes here n upon nv minus n upon v dash minus t is equal to n into 1 minus n upon n R2. Now this n is cancelled by n and this n is cancelled by n. Now you will get here 1 upon v minus n upon v dash minus t. This is equal to 1 minus n upon R2. 1 minus n upon R2. And remember this whole derivation or whole this expression is derived for the thin lengths. So for thin lengths, t is very less comparatively to v dash. v dash की तुलना में t की वैल्यू बहुत कम होगी. So at place of v dash minus t we can write only v dash because thickness is very less. So you can write here 1 upon v minus n upon v dash is equal to 1 minus n upon R2. This is equation number 2. Simply this one, equation number 1. This is the refraction through the second surface, and you can finally arrange in the proper way like this one here. On adding equation 1 and 2. On adding equation 1 and 2. Equation 1 और 2 को ऐड कर देंगे तो मिलेगा यहाँ पे n upon v dash minus 1 upon u, इसका लेफ्ट हैंड साइड, और प्लस इसका लेफ्ट हैंड साइड, प्लस 1 upon v minus n upon v dash. This must be equal to n minus 1 upon r1 plus 1 minus n upon r. This one. And now see here, minus n upon v dash is cancelled by plus n upon v dash. And here you will get 1 upon v minus 1 upon u is equal to. Now you look here, n minus 1 upon r1, this one is 1 minus n upon r2. If you will make it n minus 1, यहाँ पे 1 minus n है. If here n minus 1, here 1 minus n. तो अगर हम यहाँ इसको n minus 1 करेंगे तो यहाँ इसको माइनस करना पड़ेगा. तो you will take here n minus 1 and here when you will take n minus 1, here becomes minus. So here take n minus 1 outside and in bracket you will get 1 upon r1 minus 1 upon r2. This one. And in case of convex lens, I hope maybe all of you know, if the object is placed at infinity, then its image is formed at focus. In the case of a convex lens, if the object is at infinity, then its image is formed at focus. I hope maybe all of you know this formula, 1 upon v minus 1 upon u is equal to 1 by f. So remember this. So in case of convex lens, if the object is placed at infinity, if u is equal to infinity, then its image is formed at focus, means v is equal to f. Now in this formula, at place of v write down f and at place of u infinity. So you will get here 1 upon f minus 1 upon infinity is equal to n minus 1. 1 upon r1 minus 1 upon r2. And you know 1 upon infinity 0. So you can get here 1 upon f is equal to n minus 1, 1 upon r1 minus 1 upon r2. So you can write final equation 1 upon f is equal to n minus 1, 1 upon r1 minus 1 upon. This final result, this result is called lens maker formula. It means for the lens maker formula, we will use this one formula. 1 upon f is equal to n minus 1, 1 upon r1 minus 1 upon r2. Where f is what? Focal length of that lens. And refractive index of denser medium with respect to rarer. ये डेंसर मीडियम जैसे क्या है ग्लास, रेयर मीडियम अगर वो एयर में रखा है तो ग्लास विद रिस्पेक्ट टू एयर, किसी लिक्विड में रखा हुआ लेंस तो लेंगे रिफ्रैक्टिव इंडेक्स ऑफ ग्लास विद रिस्पेक्ट टू लिक्विड -1 1 upon r1 plus 1 upon r2. Now ये two question arises here कि focal length of the lens is depends on which factor. So focal length of the lens is depends on two factors. First, the focal length is depends on refractive index of material of lens as well as radii of curvature of its spherical surfaces. So dependence of focal length means the focal length is depends on radii of curvature of spherical surfaces as well as the refractive index of material of lens. Now, dependence of the focal length of the lens. You know, in the lens maker formula, 1 upon f is equal to n minus 1, 1 upon r1 minus 1 upon r2. It means the focal length of the lens is depends on two factors. First, refractive index, as well as second one is what here? Radii of curvature of the spherical surface. So first I am going to take what here? Dependence of focal length of the lens upon refractive index. And in this case, upon refractive index, we will consider the three cases. First, suppose if the lens is immersed in a liquid, लेंस को हम ऐसे किसी लिक्विड में इमर्स कर दें या ऐसे किसी मीडियम में रख दें, in which the refractive index of liquid with respect to air is less than the refractive index of material of lens. It means first case I am taking, if the lens be immersed in a liquid whose refractive index with respect to air, किसका refractive index with respect to air? Liquid जिसमें lens immerse किया गया. It means the refractive index of liquid with respect to air क्या है? कम है. Is less than the refractive index of material of lens. किससे? उस lens के material के refractive index से. इसका मतलब रिफ्रैक्टिव इंडेक्स ऑफ लिक्विड विद रिस्पेक्ट टू एयर जिसमें लेंस को इमर्स किया गया वो लेस है किससे? रिफ्रैक्टिव इंडेक्स ऑफ मटेरियल ऑफ लेंस. और लेंस किस मटेरियल का है? जैसे ग्लास का. इट मींस रिफ्रैक्टिव इंडेक्स ऑफ लिक्विड विद रिस्पेक्ट टू एयर इज लेस देन रिफ्रैक्टिव इंडेक्स ऑफ ग्लास विद रिस्पेक्ट टू एयर. इन दिस केस जैसे हम कहते हैं यहां पानी ले लें और यहां पे कोई लेंस हम डुबा दें इसमें, तो पानी जो है उसके लिए क्या हो गया? वो लिक्विड हो गया जिसमें इमर्स किया गया. और पानी का रिफ्रैक्टिव इंडेक्स ग्लास के रिफ्रैक्टिव इंडेक्स से क्या होता है? कम होता है. इसका मतलब ये लेंस ऐसे लिक्विड में इमर्स किया गया तो उस लिक्विड का रिफ्रैक्टिव इंडेक्स इस ग्लास के रिफ्रैक्टिव इंडेक्स से कम है. तो हाउ दिस लेंस बिहेव इनसाइड द लिक्विड? उस लिक्विड के अंदर ये लेंस कैसे बिहेव करेगा? तो इन दिस केस इनसाइड द लिक्विड the focal length of the lens will increase. इसका मतलब एयर में जो उसकी फोकल लेंथ थी और इस लिक्विड में इमर्स करने के बाद, तो लिक्विड में इमर्स करने के बाद उसकी फोकल लेंथ एयर की तुलना में क्या हो जाएगी? बढ़ जाएगी. बट द नेचर ऑफ द लेंस भी रिमेन सेम. लेकिन नेचर ऑफ लेंस नहीं बदलेगा. कहने का मतलब अगर कॉन्वेक्स लेंस को हम डुबा रहे हैं तो इट बिहेव्स इनसाइड द लिक्विड लाइक कॉन्वेक्स. और इफ कॉन्केव लेंस को हम डुबा रहे हैं तो भी इनसाइड द लिक्विड इट विल बिहेव लाइक कॉन्केव. क्या चेंज होगा? केवल इसकी फोकल लेंथ. इट मींस इनसाइड दैट लिक्विड द फोकल लेंथ ऑफ द लेंस विल इंक्रीज. एंड हाउ कैन यू कैलकुलेट द फोकल लेंथ ऑफ दैट लेंस इनसाइड द लिक्विड? And in this case, you can calculate the focal length of that lens inside the liquid by using this formula FL upon FA. It means focal length of the lens in liquid upon focal length of lens in air is equal to refractive index of glass with respect to air minus 1 upon refractive index of glass with respect to liquid. हम air नहीं ले रहे हैं यहाँ पे. Be careful about this one. Upon refractive index of glass with respect to liquid minus 1. When you will solve this by putting the value, then this ratio will come greater than 1. It means FL is greater than FA. Or how can we find refractive index of glass with respect to liquid? ये इसकी absolute refractive index glass की नहीं है. तो जैसे अगर रिफ्रैक्टिव इंडेक्स ऑफ ग्लास विद रिस्पेक्ट टू एयर दिया है, रिफ्रैक्टिव इंडेक्स ऑफ लिक्विड विद रिस्पेक्ट टू एयर दिया है, तो हाउ कैन वी फाइंड रिफ्रैक्टिव इंडेक्स ऑफ ग्लास विद रिस्पेक्ट टू लिक्विड? बाय हियर this refractive index of glass with respect to liquid you can write in terms of their absolute refractive index. And how you write in the terms of their absolute refractive index? Refractive index of glass upon refractive index of liquid with respect to air. It means refractive index of glass with respect to liquid you can write is equal to refractive index of glass with respect to air upon refractive index of liquid with respect to air. So by using this formula we can find out the focal length of that lens in that liquid or in that medium in which it kept. तो पहला केस क्या मिला कि अगर लेंस को किसी ऐसे लिक्विड में डुबा दें जहां पे उस लिक्विड का रिफ्रैक्टिव इंडेक्स अगर लेंस के मटेरियल के रिफ्रैक्टिव इंडेक्स से कम है, तो इनसाइड दैट लिक्विड द फोकल लेंथ ऑफ द लेंस विल इंक्रीज एंड दैट फोकल लेंथ वी विल कैलकुलेट बाय यूजिंग दिस फार्मूला. नाउ सेकंड केस इज व्हाट हियर कि इफ द लेंस इज इमर्स्ड इन ए लिक्विड whose refractive index is equal to the refractive index of material of lens. इसका मतलब अगर लेंस को किसी ऐसे लिक्विड में इमर्स किया जाए तो उस लिक्विड का रिफ्रैक्टिव इंडेक्स और मटेरियल ऑफ लेंस दोनों का रिफ्रैक्टिव इंडेक्स क्या हो जाए? इक्वल हो जाए. तो ऐसे केस में इनसाइड द लिक्विड that lens is what here behaves like a transparent glass plate. इसका मतलब inside the liquid the focal length of the lens becomes infinite. और infinite focal length का मतलब क्या हो गया कि that lens is not behaves as a lens. अब वो किसकी तरह behave करने लगेगा? एक transparent glass plate की तरह. हाँ. So in this case you can say when you will use the lens, actually हम ये सब lens maker formulas निकाल रहे हैं. So when you will use the lens maker formula inside the liquid, so you will use 1 upon f और lens कहां पे है? Inside the liquid, तो यहां हो जाएगा FL is equal to refractive index of denser medium glass with respect to liquid. क्यों liquid में डुबाया गया तो surrounding medium of liquid हो जाएगा -1 and you can write here 1 upon R1 minus 1 upon R2. It means here 1 upon Fl is equal to glass with respect to liquid. You can write refractive index of glass with respect to air upon refractive index of liquid with respect to air minus 1 and here 1 upon R1 minus 1 upon R2. And you know refractive index of glass with respect to air and refractive index of liquid with respect to air. This ratio is what here? If both is equal, so this ratio becomes 1. So you will get 1 upon Fl is equal to 1 minus 1 and here 1 upon R1 minus 1 upon R2. Or finally you can say here is 1 upon Fl is equal to 0. And 1 upon Fl0 means focal length becomes what here? Infinite. It means in this case, if the lens be immersed in a liquid whose refractive index is equal to refractive index of material of lens, then inside the liquid, the lens behaves like a transparent glass plate and its focal length becomes infinite. Be careful about this one here. और ऐसे सिचुएशन में याद रखिएगा, ऐसे लिक्विड में जब लेंस डुबाया जाता है तो उस लिक्विड में वो लेंस क्या हो जाता है, इनविजिबल होता है, वो दिखाई नहीं देता है। जैसे हम कहें अगर ग्लास ले लें और ग्लास का रिफ्रैक्टिव इंडेक्स 1.5 होता है और वाटर का रिफ्रैक्टिव इंडेक्स अप्रोक्सीमेटली 1.33, जबकि दोनों इक्वल नहीं है एकदम। इसीलिए ग्लास को अगर हम पानी में डाल दें तो थोड़ा सा डिफरेंस होने के नाते वो ग्लास हमको पानी में दिख जाता है। लेकिन अगर हम कोई ऐसा लिक्विड ले लें जिसका रिफ्रैक्टिव इंडेक्स ग्लास के रिफ्रैक्टिव इंडेक्स के जस्ट बराबर है, तो इन दैट केस व्हेन द ग्लास बी इमर्स्ड इनसाइड द लिक्विड, तो वो ग्लास उस लिक्विड में दिखाई नहीं देगा। तो बी केयरफुल अबाउट दिस केस, दिस वन इज वेरी इंपॉर्टेंट। And here one more case. So what happened if the lens is immersed in a liquid whose refractive index is more than the refractive index of material of lens? That I will discuss tomorrow in the next video, and also I will give the some diagram. So today all of you go through this topic, what I have discussed about this lens maker formula and this different case. Thank you.